Okay, so right now we're assessing at what x values is the function not differentiable. So to be not differentiable would mean that the left hand derivative is not the same as the right hand derivative. Now let's look at the first function here for x is less than minus 1, and the second function for x is bigger than minus 1. That means I must first assess x at minus 1. So my left hand function would be x squared plus 3x plus 2, and my right hand function will be 1 minus the absolute value of x. Now, since we are dealing with x of minus 1, that means that the absolute value will become negative because my x value is negative. So that means that my right hand function will essentially become 1 plus x. Now we have our two functions set up, and now we're ready to differentiate and see if the derivatives are equal to each other. If they're equal, the function is differentiable. If they're not equal, the function is not differentiable. We're going to get 2x plus 3. Here we're going to get just a 1 upon differentiation. Now what do we apply? We apply the x value of negative 1. We're going to have 2 times negative 1 plus 3, which equals to a 1. And here it's already a 1. So because my left hand derivative is equal to my right hand derivative, that means my function is differentiable at x equals to negative 1. So I'm going to go back here and I will not choose choice D. Okay. Next, let's look at this function in more detail. What would make the inside of the absolute value 0? Okay, let me take this question to a different space. So this function, the absolute value function, okay, the inside of the absolute value will become 0 when x is 0. And whenever there's an absolute value, I must be able to assess it from the left hand side and also from the right hand side of the x equals 0. That means when x is approaching 0 from the left, my function will look like minus x inside. Okay, but when x is approaching 0 from the right, my function is going to become only x on the inside. You see, the absolute value, do not underestimate AB calculus. Okay, it can be negative on the inside if your x is negative region. It can be just a positive x on the inside if your x is positive region. So right now my function from the left side becomes 1 plus x. My function on the right side become 1 minus x. Now if I were to differentiate those two functions, for the left hand side I will get 1. For right hand side I will get negative 1. Now since my left hand derivative and my right hand derivative are not equal to each other when x is 0, that means my function is not differentiable at x of 0. Not differentiable. So you cannot have choice B, you cannot have choice C. Okay, and we know it's not differentiable at 0, so it has to be either A or C. What's left for me to assess is the x of 1. So now let me assess the function at x of 1. My left hand function will be this one, and my right hand function will be this one. So my left hand function is going to be 1 minus the absolute value of x. My right hand function is going to be x squared minus 1. Now don't forget that x is equal to a 1. That means x is positive, so the inside of the absolute value just becomes a positive. And now I'm ready to differentiate. So my left hand function becomes minus 1, while my right hand function upon differentiation becomes 2x. And of course now I have to apply the x of 1. That means I will get 2 times 1, which is just a 2. So since my left hand derivative is not the same as my right hand derivative, That means my function is not differentiable at x of 1. So that means my function is not differentiable at x of 1 and also at x of 0 from previously. The answer is going to be choice C.